Mercedes just unveiled the EQXX, an ultra-efficient 620 plus mile range 4-door electric sedan prototype that has caught a lot of attention. However, the truth is it doesn't appear like Mercedes actually plans to build a production version of the EQXX. Therefore, I want to make sure that we don't get bogged down into the design aspects of this prototype. Nevertheless, the EQXX prototype does show what Mercedes is able to achieve when it comes to efficient powertrains and energy-dense battery packs. And in this video, I'd like to dive into the exciting details that Mercedes shared about the powertrain and battery packs that they have developed for this prototype, and talk about how this technology could soon find its way into production Mercedes-Benz electric vehicles. Over the years, I've learned to keep my expectations pretty low when it comes to prototype electric vehicles, because in the end, when the production version actually comes out, it's generally a much more watered down version of what the prototype was initially. Beyond that, when it comes to the EQXX, as I mentioned a minute ago, Mercedes hasn't made any statements that lead me to believe that the EQXX will ever be a production vehicle, but rather, Mercedes said in the reveal presentation referring to the prototype, "It's a trailblazer, which underlines where our company is headed." So if the EQXX prototype is indeed a trailblazer and reveals where Mercedes-Benz is going in the future, then their future has a big focus on efficiency. So let's dive into the details about the very efficient powertrain and also the very energy-dense battery packs that we could find in future Mercedes-Benz vehicles as foreshadowed by the EQXX prototype. Once again, if you have not already, I'd like to remind you to go over to Cleanerwatt.com and check out the 2022 Electric SUV Buyer's Guide, which details a number of electric SUVs that are available for the year 2022, and also a number of electric vehicles that are coming out in 2023 and 2024. And this digital magazine is able to be purchased and instantly downloaded at Cleanerwatt.com. Currently, the longest range production electric vehicle available in 2022 is the Lucid Air, with up to 520 miles of EPA estimated range from a 118 kilowatt-hour battery. Also impressively, the 2022 Tesla Model S offers up to 405 miles of EPA estimated range from approximately a 95 kilowatt-hour usable battery capacity. When it comes to Mercedes, their EQS 450 Plus sedan recently received an EPA estimated 350 miles of range, and this range is achieved with a 107.8 kilowatt-hour usable battery capacity. In contrast, the EQXX prototype, according to Mercedes, should be capable of over 620 miles of range, and this is from a less than 100 kilowatt-hour battery pack. Now, to be clear, I don't actually expect Mercedes-Benz to bring out a 600 plus mile electric vehicle anytime in the near future. However, I do believe it paves the way for a 500 plus mile Mercedes-Benz electric vehicle in the future, one that could compete directly with the Lucid Air. Now, when it comes to the EQXX prototype and what makes this kind of efficiency possible, there are a number of things mentioned by Mercedes, like for instance, the super low coefficient of drag of just 0.1716, and also the very unique weight-saving 3D bionic structure. However, when it comes to an actual production electric vehicle that could be made with technology from this prototype, I don't see a production electric vehicle from Mercedes having a drag coefficient of just 0.17, nor do I actually believe that this bionic 3D printed structure will find its way into a production vehicle. However, I do believe that the battery technology and the powertrain technology and the efficiencies built into that technology could find its way very soon into a production electric vehicle from Mercedes. So when Mercedes describes a 900 plus volt powertrain that operates at a 95% efficiency and a battery pack that is more energy dense both volumetrically and gravimetrically than even the impressive Tesla Model S Plaid, it's worth taking notice. In the EQXX press release, Mercedes specifically mentions, quote, "With expert engineering and Formula One thinking, our battery chemists squeezed the energy of the EQS into the dimensions of a compact car. The battery pack in the Vision EQXX holds almost 100 kilowatt hours of energy, yet has 50% less volume and is 30% lighter than the already benchmark pack in the EQS. Later on in the press release, Mercedes also mentions, overall, the battery weighs around 1,091 pounds, including the one box. And we'll talk more about the one box in just a minute, but basically it's the all-in-one box that holds all the power electronics for the battery pack. So if this new battery from Mercedes has 50% less volume than the EQS battery and also is 30% lighter, then it must be much more energy dense. When it comes to volumetric energy density, which simply expresses the amount of watt hours in a specific unit of volume, Mercedes mentioned that this EQXX battery pack has a volumetric energy density of almost 400 watt hours per liter. Unfortunately, they did not share the gravimetric energy density values. However, if you do some simple math, the EQXX pack, they describe the weight and the size, etc., should have a gravimetric energy density of right around 200 watt hours per kilogram. Notice that this pack level energy density would represent approximately a 24% improvement when it comes to watt hours per kilogram over the current 2022 Mercedes-Benz EQS 450 Plus, a 17% improvement over the Lucid Air Dream Edition, and even a 7.5% improvement over the 2022 Plaid Model S. As you can see, these energy density claims from Mercedes are impressive. However, I believe they're also at the same time very realistic, and I believe we'll actually see this battery technology find its way into a future Mercedes-Benz EV in the not too distant future. Now, do note that I expect Tesla's new 4680 structural battery packs to be a large leap ahead when it comes to pack level energy density, and it's very possible that we could see pack level energy density numbers for the Model Y 2.0 structural battery pack of somewhere around 245 watt hours per kilogram or even greater. However, if Mercedes is able to deliver a production battery pack with a pack level gravimetric energy density of 200 watt hours per kilogram or even greater, this would still put them clearly in the number 2 spot, which is also very impressive. To give this a little perspective, according to my estimates, based on the estimated battery pack size and the official energy density values, the current EQS battery pack should weigh around 713 kilograms or 1,572 pounds. If Mercedes were able to incorporate this new technology from the EQXX battery pack into the EQS battery pack, they would be able to shed 138 kilograms or somewhere around 304 pounds without shrinking the battery size. This energy density change alone would allow the EQS 450 Plus curb weight to be more in line with a smaller Lucid Air. Now, while a 300 plus pound reduction may not seem that drastic, when you actually come down to the numbers, it makes a big difference in vehicle efficiency if you can shed somewhere around 300 pounds. So this would be an impressive improvement for even the new EQS if Mercedes were able to introduce this technology in a future version of the EQS, for instance. So with those numbers in mind, I'd like to dive now into the how this is possible and the technology that Mercedes used to improve their energy densities so much, starting with the improvements in cell level energy density. According to the official EQXX press release quote, the substantial increase in energy density comes in part from significant progress in the chemistry of the anodes. Their higher silicon content and advanced composition mean they can hold considerably more energy than commonly used anodes. As I've mentioned in detail in previous videos, there's a push right now in battery cell manufacturing and battery cell engineering and development to increase the amount of silicon in the battery anode, thus improving the energy density of the battery cell itself. Unfortunately, as Tesla talked about in detail at Battery Day, silicon has some stability issues caused by volume expansion, which, if not accounted for, can lead to battery failure and thus requires a number of chemistry and engineering tricks to make it work in a production battery cell that has a long life. Based on comments from Mercedes, it appears that, like Tesla, they figured out ways to increase the silicon content in their battery anodes, thus improving the cell level energy density. Another key technology that allowed Mercedes to increase the energy density of their battery packs comes down to how they package the power electronics in their battery packs. The EQXX press release mentions the following about the power electronics consolidation. The separate compartment for the electrical and electronic components, called the one box, likewise made room for more cells, which added benefits for installation and removal. Tesla was definitely the pioneer when it comes to very compactly and very efficiently packaging the power electronics needed for an electric vehicle, whether that be for the powertrain or whether that be for the battery pack. But now it appears like Mercedes has taken a page from Tesla's book. Mercedes' new one box allows them to have more room for battery cells, thus once again improving the energy density of the battery pack. Now moving on to the powertrain that's built into the EQXX. In the Mercedes-Benz press release, they mentioned that the Mercedes EQXX powertrain has an output of around 150 kilowatts and that it operates at a 95% efficiency. Conventional gasoline vehicles only convert around 12 to 30% of the energy stored in gasoline to power at the wheels. When it comes to an efficiency comparison to Tesla's electric vehicles, a Car and Driver article from September of 2020 mentioned, quote, Tesla told Car and Driver that the motor in the Model S has gone from 80% efficient to 90%, with peak efficiency at 94% during the EPA test cycles. This article also mentioned, according to Tesla, if you improve motor efficiency by 8 to 10%, the range will improve by 15 to 18%. Unfortunately, I was unable to find reliable data for the efficiency of the 2022 Tesla Model S, either the Plaid or just the regular all-wheel drive version. However, since Tesla is always improving efficiency and improving their technology, I think it's very possible that Tesla is also somewhere around that 95% efficiency number as well. Like the Lucid Air, the EQXX operates with a 900 plus volt system, and moving from a 400 volt system like the Model S uses to a 900 volt system allows for the motor itself to shrink in size and maintain a similar power output. Thus, if you're able to have a smaller motor, this reduces the weight once again and improves the efficiency of an electric vehicle. This Autocar article from June of 2020 helps explain why a 900 volt system can be smaller and lighter than an equivalent 400 volt system. Quote, to increase the power in watts that an EV system can deliver or charge that it can accept, either the voltage or the current, meaning amperage, needs to be increased. The problem with using a higher current is that it requires bigger, heavier cables with thicker insulation, and it generates more heat. So the alternative is to increase the voltage instead, hence the introduction of 800 volt electrical architecture by Porsche. In addition, when it comes specifically to electric vehicle motors, this Drive Mode article from February 2021 explains, higher voltage systems also offer a number of key weight and mass saving advantages. The reduction of copper is one of these. Using higher voltage systems can lead to the amount of copper used in motors being significantly cut. Now, as I mentioned earlier, the power output of the powertrain built into the EQXX prototype is only around 150 kilowatts. Thus, as you can see on this chart, this vehicle is built for efficiency and not quickness and speed. However, when you combine a 900 plus volt system with a 150 kilowatt motor, if you do the simple math with the equation watts equals volts times amps, this powertrain will draw somewhere around 160 amps or less. And as we mentioned earlier, if you have a lower current or a lower number of amps, then that system should create quite a bit less heat and thus be more thermally efficient. So in addition to this 900 volt system allowing for smaller, lighter motors, it also generates less heat and thus requires not as complex and not as large of a thermal management system, thus once again reducing weight. As Mercedes mentions in the EQXX press release quote, the exceptional efficiency of the electric drive unit means it generates only minimal waste heat. This helped keep the thermal management system extremely small and lightweight. So I don't know about you, but I'm actually quite impressed with this battery pack technology and this powertrain technology that Mercedes is developing. And I'm really looking forward to seeing this technology in a future Mercedes-Benz production electric vehicle. Please let me know what you think about this battery and powertrain technology from Mercedes, and also what you think about the EQXX prototype. I'd love to hear from you in the comments section below. Well, thank you so much for watching this video all the way through to the end. I'd like to take a moment to thank the Patreon supporters who support me every month and help make this content possible. A special thank you to my performance supporters and also the other supporters listed on the screen. If you'd like to find out more about the Patreon community I've set up, I'll put a link in the video description. Thank you so much.